Hi everyone, and welcome to the series of Electrical A6 Power System and Machines PO exam. And this is a very recent question from the May 2025. And before we start, I'd like to mention something about the A6 exam compared to the A1 and B7 that I usually solve several questions about them. This is the least expected exam. So in this exam, the questions were basically not very much the same, following the same trend. They are very easy, actually. And some of them are basically from general knowledge, some of them even from A1 exam. And some of them is basically from B7. So I will be solving a couple of these questions in the coming few days before your exam. So let's see this question. So here it says there is a watt meter and var meter. So basically here you are measuring both the P and the Q. And you have a single phase line that feed an AC motor. So basically here you will have an AC motor. So this is AC motor. And it's a single phase, it's not a three phase. So you have var, you're measuring the var, and you're measuring the watt, both the real and the reactive power. And the voltage here is 120 volt, and you are asked to find a couple of things. So basically, what do we know here? We know that your P, the power is 1800 watt, and your Q is equal to 960 var. So then it asks for the in phase and the quadrature IB and IQ, the line current, apparent power, and phase angle. Very simple, straightforward question. It tests your basic understanding of the power calculations. So from the P and the Q and knowing the power triangle, this is your power triangle, this is your theta, this is your P, and this is your Q, and this is your S. So that would be our main focus in this question. From this, I can find the theta, which is the power factor angle, which is the angle of the current, or it's basically the difference between the angle of the voltage minus the angle of the current. All of them is this theta. So it's tan inverse of Q over P, tan inverse over 960 over 1800, and this would make the angle theta is equal to 28.1. This is very critical to solve this question. Now you need to find the current. I will find B before A. So the I line, either you said it's equal to P over V cosine theta, which is equal to 1800. Now this is only the magnitude, divided by the 120 times cosine of 28.1, and this will give you 17 amp. Or it is Q over V sine theta, which is equal to 960 divided by 120 sine of 28.1, and this is also equal to 17 amp. So we found I line. Now to find the in phase and the quadrature component, the I phase is equal to I line cosine theta, which is equal to 17 times cosine of theta, which is basically 28.1, and this will give me basically the current equal to 15. So I quadrature is equal to I line sine of theta. Now theta here, sorry, it should be minus, not plus. Why? Because theta is equal to theta V minus theta I, okay? And theta V, we can take it as 0 as our reference. So your theta I will equal to minus theta or equal to minus 28.1. So this has to be equal to 17 times sine of minus 28.1. But as you know, in cosine, plus and minus, it doesn't really matter. And this will give me minus 8. So this is 15 amp minus 8 amps. Your I line is equal to 17 angle of minus 28.1, which is equal to 15 minus J8 amps. So this is in polar format, and this is in rectangular. This is your I in phase, and this is the quadrature components. Okay, so that is basically your current I line. Then it says find the apparent power. Again, from the power triangle, as we know, we said that this is your P, this is Q, the apparent power is your S. So your S as the apparent power is equal to P square plus Q square, which is equal to 1800 square plus 960 square under the square root, and this will give me S equal to 2040 kVA. The phase angle between the line voltage and the line current, we already found that the angle is basically equal to 28.1. So as you can see here, it's a very, very straightforward question.